It's a nice lightning storm outside. Can you hear that thunder? Ooh, I love a good lightning storm. Yeah. Perfect, apropos. Correct observations, incorrect explanations. We all grew up being told that lightning strikes from cloud to ground, and we never learned anything like stepped leaders. Yeah, you could look up stepped leaders. Kind of rare to have pictures of stepped leaders where these little streamers, these little plasma streamers that are sent up from the ground, and some connect with the charge up in the upper atmosphere and some don't. Fascinating stuff. Everything we think we understand about nature, of course, is upside down and backwards. I love it every time I made a video on gravity. I've not made an enormous amount of videos on gravity, but every time I do, and so many so-called scientists, they'll actually talk about the force of gravity. What's interesting, because gravity is not a force, is this is not really a video on gravity. I wanted to tie in magnetism here. They will say something to the effect of, obviously they'll say that gravity is a force, and gravity is the complete opposite, the antithesis of a force. So if you have the fundamentals of gravity wrong, then you probably don't really understand anything about gravity, but neither does the rest of the world. I mean, knowing these things, having a lust, like an insatiable lust, which lust is not really the right word, is a desire, the ancient Pali word tanha. There's only one wholesome desire, according to ancient Pali, that's the desire for wisdom, because it can be fulfilled. All their desires, of course, are a bottomless pit. You know, they, of course, destroy people's lives and the lives around them. So there is one wholesome desire versus kusala, wholesome versus akusala. So all desires are unwholesome versus a wholesome desire. And you'll see, craziness of like the FE people, or like the electric universe people. I don't know why people keep associating me with electric. Not only do I have nothing to do with the electric universe people, I want nothing to be associated with those people. They will say things to the effect that gravity doesn't exist, and I've said this too, but I gave the caveat that an autonomous field modality to be called gravity doesn't exist. I mean, there's nobody on Earth that, of course, can deny that phenomenon. It's like people leave silly little comments to me saying, well, gravity doesn't exist. So let's forget about the word. I've said specifically that the autonomous field modality called gravity doesn't exist, but the phenomena does exist. Let's get back to magnetism and tie magnetism in with gravity. Gravity specifically, of course, is a centrifugal force and motion vector, that defines the second half of the conjugate field geometry of the entire universe, which is the dielectric, and the loss of that energy or inertia manifests as the centrifugal force vector that we call magnetism. And this is a little bar magnet, a little cube magnet here in the middle, and we've seen this in countless school books. You'll actually see, the magnetic lines of force. That would be accurate. That's actually nature's true force. Around this magnet, a magnet is split up. North Pole and a South Pole. Technically it's not. It's the incommensurable point geometry of a magnet, because you can't slice a magnet and separate out the North Pole from the South Pole. So this is a correct view of magnetism. Yeah. But it's a tiny little magnet, and that's how human beings have been looking at it. There's all these magnetic and electrical phenomena that couldn't be explained rationally. We had to actually work out equations to describe observations, but equations and observations and repeatable results are not explanations. And it turns out when you take a larger magnet, and I've shown this in, God knows what, 3,000 videos at least? Say we're looking top down on a large cylinder magnet. The only thing that we can actually denotatively call magnetism is this outer edge here. A magnet has zones that is visible underneath the supercell, which I'm rebuilding over here. I've got thousands of videos with this supercell. Yeah, that's the only part that's actually magnetism. We have an intermediate zone right here, and the center part of which you can see underneath the supercell is this big black spot. Yeah, so we have constructive and destructive interference between the magnetic and the dielectric. But the only thing people are interested in when they hold a magnet are those magnetic centrifugal flux lines. So we have this ab extra phenomena with no substantiality to it. And then when we get to the issue of what human beings have been talking about for thousands and thousands of years, and I'm getting back to gravity here very quickly, is that this idea of a magnetic attraction. Well, we have two magnets here, and we know they have a magnetic field around them. This is well established. Every scientist agrees. And then therefore this acceleration, where they accelerate, not towards one another as it turns out to be, is also magnetism. Never we're going to call it magnetic attraction. And that belief exists today in every branch of the world. And I'm the first person to say, not Walter Russell. Walter Russell didn't say it. He's got a lot of ingenious little diagrams on magnets and magnetism, but even he never defined what magnetism was or what a magnet was, since a magnet is qualitative, not quantitative. Walter Russell was a genius. I digitized Walter Russell's works, and I'm a big fan of his works. He's a lot more accurate than most people are. Very brilliant old guy, but he actually never told you what magnetism was or what defined a magnet. But there's no such thing as magnetic attraction. Specifically, that's point source. And it is not magnetism at all. Mutual acceleration is not only not a force, which is what magnetism is definitionally, centrifugal force in motion, towards spatial, you would say spatial geometry, you should say technically, towards spatial creation of geometry, the loss of energy or inertia, the dielectric, excuse me, I said dialectic there, once again, excuse me. So anyway, I've explained 1,000 times in way over 2,000 videos, that the field around a magnet is not merely magnetism. I've proved this 1,000% over and over and over again. Every current branch of science says, well, gravity is the weak force. Well, not only is gravity not a force, once again, they keep saying gravity is a force, and it's not a force. They say it's weak. Well, we have a lot of other analogies in regards to fields, including magnets too, because as I've explained before, a magnet becomes a magnet, it's quantitatively identical. But it doesn't impress anybody. It's either a ferrite magnet or a samarium cobalt or a neodymium iron boron, but it doesn't impress anybody. It's not impressive. It's an expensive piece of neodymium iron boron with usually a nickel or chromium plating on it. Totally unimpressive. Useless. Useless. But once it becomes a magnet, it's quite fascinating with fascinating effects. So now it's a point source object. Before it was weak, and now that we've made it a magnet, even though it's quantitatively 100% identical, it has interesting phenomena that's really strong. Some of those monster magnets I have will literally break your bones if you get your fingers caught between them. Many people, unfortunately, have learned that the hard way. So, point source gravity is strong. What's an example of point source gravity? Just using the word gravity, even though this autonomous field modality that we call gravity doesn't exist, but we could take that further. Human beings love to pigeonhole things. Ice and steam don't exist either. They're not autonomous. They're modalities of ice. We can take that further, and something I've said a million times. Magnetism is the dielectric field. That which we call gravity and that which we call so-called magnetic attraction, which is not magnetism at all, are both identically one and the same thing, except one's point source and the other one's non-point source. Same is true of a magnetic field around a magnet. Before it becomes a magnet, it's totally unimpressive, yet if you have two lead balls, this experiment's been done for a long, long time. It's called the Cavendish experiment. You actually suspend these enormous lead balls or any sort of matter. Lead is best since it's incredibly dense. It'll start to swing towards one another. In other words, the induction of acceleration, or conventionally what's called gravity, will occur in non-point source matter, like non-magnetized magnets before they become magnets, or lead balls, for example. So, non-point source gravity, point source gravity is incredibly strong, and this, of course, is what we call magnetic attraction. Examples of point source gravity are black holes, the phenomena that we call black holes, but we don't have any other parallels of point source gravity here on Earth, except for some of the field propulsion craft created by the government, but that's a matter for another discussion. This is like saying light is weak. like a conventional light bulb is weak. Sorry about that, a little frog in my throat. Well, incoherent light is weak, but point source light is incredibly strong. Qualitative, not quantitative. 5-watt laser is dangerous. It will permanently blind you and burn a hole in your backside. 5-watt light bulb is useless. They're both 5 watts. They're quantitatively identical amount of light energy, but what's the difference? There is point source phenomena that we call gravity, which is mutual mass acceleration towards a null point. The same is true of magnets. Say, once before these become magnets, and are magnetized where they're created, which is like 99% of them are created in China, they're completely unimpressive. They're just like these lead balls here. These are lead balls actually wrapped in electrical. Just equally unimpressive. You turn them into point source objects, they're quantitatively identical, but the qualitative nature has changed such that it is no longer, they call it a weak force. They love to say weak force. Gravity is not a force, and the only reason it's weak, we're talking about incoherent mutual mass acceleration, as in the Cavendish experiment, not in point source gravitational acceleration, the phenomena thereof, the field phenomena, wherein there's mutual acceleration towards a null point, as in the case of black holes. But we don't have any other parallels of point source gravity here on Earth. But that which human beings call magnetic attraction, sorry, I got a frog in my throat, not literally, magnetic attraction is the exact same thing. It's not magnetism at all. It is dielectric. Yeah, that big black spot that you see on every ferrocell video, yeah, that's where the phenomena that human beings call gravity is occurring. The only place where magnetism exists is on the centrifugal edge here. And then there's an intermediate zone on the middle of the magnet. This is looking top down on a cylinder magnet, so. Gravity is the dielectric. It is not electrical. This is from a book from 1917, so over 100 years old, by a man with way more patents than Tesla, far smarter than Nikola Tesla, and also, too, perfected Nikola Tesla's AC motor. Unfortunately, to a large extent, in dealing with dielectric fields, the prehistoric conception of the electrostatic charge, i.e. the electron, on the conductor still exists, and by its use destroys the analogy between the two components of the electric field, the magnetic and the dielectric. This makes consideration of dielectric fields unnecessarily complicated. See, electricity is a hybrid of dielectricity and magnetism. It's not an autonomous, like the nonsense of the EU people, the electric universe. They say gravity is electrical. No, it's not. It's dielectric. These people in these weird little groups, the FE people and the EU people, the electric, they've never read any of the great masters of field theory vis-a-vis Heaviside, Faraday, Steinmetz. They've not read them. They keep thinking in terms of electric, and that's it's just mental incompetence, unfortunately. Upon becoming a magnet, there is no point source incommensurability in the conjugate fields of the magnet, which then, of course, creates the ab extra field phenomena around the magnet, which, of course, people think incorrectly is being emitted by the magnet. It is of the field around the magnet. It is not an emission of the magnet. Yeah? Same fallacy human beings have all over the place, that light is an emission, a wave, a particle, wave-particle duality. They think a magnet is emitting a magnetic field, and it's not. It is of point source nature that it influences the medium that is everywhere and nowhere. It has no Cartesian value around it. The same with sound. Sound is not an emission at all. Sound is a disturbance of the oxygen and nitrogen, i.e. the air. Nothing emits sound. It sets up a perturbation of the medium. Magnetic field is a disturbance with a specific geometry of the medium, that being the aether. Magnetism is the extrinsic attribute of the dielectric field. When someone says there is no such thing as gravity, it's all well and fine to say that, because I've said that before, but what I mean, and I've explained explicitly, is there's no autonomous, separate, unique field modality called gravity, any more than there's any such thing as ice and steam. Sure there is. It's like it's just a water modality. Magnetism is like ice is to water. It is the extrinsic side, the force vector side, of the loss of energy or inertia of the dielectric. That's the reason why a magnet Every textbook in high school, college for 100 plus 200 years, hey, we have a magnetic field around the magnet. It's a lines of force. Well, magnetism is a force. They did get that right. But that's not true. That's less than half the story, because in the true case of the magnet, what we have here in the center of every magnet is not magnetism at all. It is the hyperboloidal geometry of increasing inertia and acceleration towards non-Cartesian counterspace, i.e. the plane of inertia. Specifically, its geometry is hyperboloidal. The cross-section of this, i.e. the magnetic field, of course, is toroidal. You're just looking at a cross-section of a donut, a torus here. Those two are the conjugate geometries of the entire universe. The negative image of a torus is a hyperboloid. The negative image of a hyperboloid is a torus. Here's the last quote from Charles Proteus Steinmetz, same book. Electrical discharges, waves, and impulses, 1917. In electric currents containing energy stored in the magnetic and in the dielectric fields, the change in the amount of stored energy occurs by a series of changes from the magnetic to the dielectric, and back again from the dielectric to the magnetic. This is just constructive and destructive interference between the conjugate geometry fields of the entire universe. The dielectric to the magnetic of stored energy. You can't understand electricity unless you've understood it correctly, and Steinmetz was a genius. Way smarter than Nikola Tesla. Hate me for saying that? I don't care, it's accurate. Way more patents, he perfected Nikola Tesla's AC motor. Way more patents than Nikola Tesla. Truly a genius. There's a lot of stuff he didn't understand. He ultimately did make the mistake in his book calling it dielectric force. He didn't understand the difference in the antinomies of force, motion, inertia, and acceleration. It's dielectric, of course, is the opposite of force. It is inertial. The true original definition of inertial, meaning towards or capacitance, towards energy, towards capacitance, which has its own geometry. In the constructive and destructive interference between the magnetic and the dielectric, that geometry, of course, is a hyperboloid, which is directed at non-Cartesian pure potential, i.e. capacitance, i.e. energy, i.e. is inertial. So there's such a nuance of distinction. Mother Nature is not a complicated chick. I can explain energy and magnetism and dielectricity to a child. It is not that difficult. I would need wire forms of a hyperboloid or just an hourglass. I got a bunch of hourglasses in Florida, but I don't have any here. Geometry of the torus, and you could explain the entire nature of the universe. You could explain gravity to a child. You could explain what magnetism is. Like, you know, even a child understands, you know, ice is really just water, right? Yeah, it's hard water. Yeah, I know that. You know, when you get water cold, it turns out. So magnetism is to the dielectric as ice is to water. Oh, it makes it simple. Yeah. Then explaining point source would become easy, explaining that to a child too. You say, oh, you know what a laser is? Every child today knows what a laser is. So even a weak 200 milliwatt laser is dangerous to your eyes, and it will burn you. Even a 200 watt one will. Like a spatial filter. Most people don't realize that holograms actually were created before lasers existed. Gabor created lasers using mercury arc lamp, and he put a pinhole aperture which created a point source for the mercury arc lamp light. And then he was able to create genuine holograms before lasers themselves were invented. Because that's what a laser is. So a laser is coherence. Well, that's attributionally correct, but what a laser actually is point source light. So you'd have to explain point source fields to a child. It's because, you know, I try to explain it to adults, but their brains are so wrapped up in this nonsense. We got gravity over here. Gravity's a force. Like, no, it's not a force. We got magnetic attraction over here. It's like, well, I know these are two magnets, and they're accelerating towards one another, but to call it magnetic attraction is not only a misnomer, it's completely incorrect. There's no such thing as magnetic attraction. The thing that you're calling magnetic attraction is point source gravity. The thing that human beings call gravity. Look, here we go, we got gravity. Yeah. Well, that particular phenomena is no different than the phenomena that you're referring to as magnetic attraction. The only distinction is that one is point source and the other one is non-point source. They both follow the simplex geometry. Is it a point source energy? device. In the case of a magnet, or a laser, or a pulsar, or a quasar, or a black hole, these are point source objects. There are other examples in nature. Things that partake of point source field, either emissions or inertial, are quite fascinating. Because most of the technological world that we have is built upon magnets and lasers. There's so many magnets in this little freaking computer, it will shock your mind, by the way, for example. It's how we write binary. Doesn't matter if it's a solid-state drive or a conventional platter hard drive. Still requires magnets! Writing of binary data. That's how our data is stored. Not all of it. I mean, some of it's optical, but then you're still talking about... you talk about optical, you're talking about lasers once again. So we're either talking about writing all our data with magnets, which are point source objects, or writing them on optical or magneto-optical devices, which is also another point source device, i.e. a laser. So point source objects actually define 99% of technology that we're so impressed with today. There's never been a YouTube video on that fact. Nobody ever talks about that because nobody understands field theory. The people that say they do, these PhD physicists, they don't even know what magnetism is. They've never defined the term energy. They've never defined the term field. Anyway, if you want to contact me, my email's in the description below. Any donation is always warmly welcome, or you could just email me, tell me what you didn't like about this video. I am an open-minded, conventional person, and I like listening to people, and I read every comment, so comment away. Thank you so much. Lux Everetas. It's still thundering out there. I love thunder. Except for when it, like, kills the power. That's lightning, though. Which is a discharge into counter space.